Signor Presidente Supsi, Alberto Petruzzella, distinte signore e signore e greci signori, cari colleghi, cari ospiti, siamo contenti di essere qui e ci auguriamo un cordiale benvenuto. We are here to discuss the framework conditions of a digital revolution. What can we do to be informed for digitalization and to be sure that nobody is left behind? We want to take everybody with us with digitalization, and we are here to discuss this point. Our motto is as follows: prendi la palla e passala. Soluzioni nascono del lavoro di team. Allora, we have to pick up the ball and pass it on, because only together we will find solution for this new revolution. We are also here to innovate, to take risks, and to pave the way for new solutions. That's why we invited a spin-off of ETH Zurich, Seer Vision, and they are testing today. So it's not about filming, it's about testing. They developed a robot camera which can register lectures. And as they had the lectures, they saw that it was really very static. And obviously, we should move a little bit. And it would be more interesting to have films on podcasts where something happens. And they are here to test. And we are not sure whether we will see a film in the end, but it's a testing ground, and that's about innovation as well. Le presentiamo Seer Vision. Fanno oggi una beta test della loro robot. Vediamo se riescono a fare un film, perché sarebbe bello di averlo alla fine. E se non riusciamo, almeno sappiamo come la loro tecnica può essere implementata. Potete anche vedere il loro lab sul palco, sono lì installato con 5 colleghi dell'ETH Zurich. E adesso ho la gioia e l'onore di annunciarvi il Saxophone Quartet del Conservatorio della Svizzera Italiana. Vediamo, c'è un Gershwin che ci aspetta. relax, and then we get to move again. Thank you very much, and we will hear them again. Now I have the honor to announce the official il saluto ufficiale di Alberto Petruzella. We know him as a banker in management, but he is also a man of education. And so he brings together education and economy. And I'm happy to hear the floor is yours, Alberto Petruzella.
È per me un piacere particolare aprire questa giornata di lavoro e saluto cordialmente i membri della Fondazione Balzan di Milano e Zurigo, i membri del Consiglio del Politecnico di Zurigo, i rappresentanti di Economy Suisse, i rappresentanti dei sindacati e i rappresentanti dei partner di Digitale 21, o meglio delle Accademie Svizzere delle Scienze, della Scuola Universitaria Professionale della Svizzera Italiana, dell'Università della Svizzera Italiana, dell'Istituto Universitario Federale per la Formazione Professionale e di Sciences et Cité. E infine gli ospiti della politica, della scienza, dell'educazione e dell'economia. Quando circa un anno fa il presidente dell'Accademia Svizzera delle Sciences, Maurice Campagna, mi parlò dell'idea di organizzare qualcosa assieme in Ticino, la mia risposta fu subito positiva ed entusiasta. Aveva per le mani, scuserà il professor Capasso l'espressione poco fine, un relatore d'eccezione, il professor Capasso appunto, e ce lo metteva a disposizione. A Maurice, che è un fisico pure lui, nell'ambito della sua tesi di laurea al Politecnico di Zurigo, ha realizzato una nuova tecnica sperimentale con la spettroscopia di elettroni spin polarizzati da corpi solidi, brillavano gli occhi quando mi parlava delle scoperte rivoluzionarie del professor Capasso e cercava, lui, di spiegare a me cos'è un laser a cascata quantica. Per un giurista che ha fatto tutta la vita nella finanza, temi alquanto ostici. L'unico spin che conoscevo era quello che ho cercato per anni invano di dare a una palla da golf, e quanto ai laser a cascata quantica per me erano e sono vera e propria fantascienza. Ma anche per qualcuno come me a digiuno di scienze dure, come le chiama il professor Martinoli, anche lui fisico ed ex rettore dell'Università della Svizzera Italiana, che nel consiglio dell'USI ogni tanto ci portava questi esempi della scienza dura. Quindi anche per me Premio Balzan e Harvard University sono due concetti chiarissimi. Abbiamo un relatore d'eccezione ed è un'occasione da non perdere. Che poi l'idea all'inizio fosse di fare una conferenza del professor Capasso, e adesso viviamo praticamente una settimana di relazioni e workshop in Ticino, è il merito del presidente Campagna e della segretaria generale Penzeller, iniziatori, ma poi di Susi, USI, Swivet, Economy Suisse, Sciences et Cité e decine di colleghe e colleghi che si sono messi a disposizione per organizzare un programma assolutamente eccellente. Ed infine, quando io e Maurice abbiamo cominciato a parlare di questo evento, certamente non immaginavamo che ci saremmo rivisti a Berna il 20 settembre 2017 ad assistere alla nomina di Ignazio Cassis in Consiglio federale. E quindi la presenza del Ministro degli Affari Esteri non era nei nostri primi programmi dell'evento, ma è una magnifica realtà oggi. Sulla scelta dei temi e della digitalizzazione non c'è molto da dire. La tecnologia, la digitalizzazione cambieranno in modo radicale il nostro modo di vivere e di lavorare, e quindi occuparsene è quanto mai opportuno. Per SUPSI il tema della digitalizzazione è assolutamente centrale e abbiamo ben due obiettivi nella nostra strategia strettamente legati al tema. Per quanto riguarda la ricerca e l'innovazione, ci impegniamo a lavorare per sostenere la competitività e la capacità di innovazione delle aziende e istituzioni del territorio. E per quanto riguarda la formazione, cerchiamo tramite piattaforme e ambienti digitali intelligenti di offrire un laboratorio aperto dove sperimentare nuove tecnologie ICT, creando nuovi ambienti di collaborazione, apprendimento, ricerca e lavoro. Mi rallegro che nei giorni scorsi si sia parlato molto di digitalizzazione e formazione. Che abbiamo colpito nel segno ce l'ha detto questo lunedì il ministro dell'economia Schneider Hammann, in visita anche lui in Ticino, ricordandoci che l'invidiabile situazione sociale ed economica di cui gode la Svizzera potrà essere preservata solo se riusciremo ad avere un sistema formativo, performante e di punta a livello mondiale. La tecnologia diventerà sempre più importante nella nostra società e deve essere sfruttata ogni occasione per cogliere i nuovi trend, cercare di capire in che direzione va il mondo e fare di tutto per essere fra quelli che vivranno questa rivoluzione come un'opportunità e non come un rischio. Chiudo qui ampiamente sotto i 15 minuti concessimi dal programma, perché il sottoscritto in Ticino avrete, temo, ancora qualche occasione di servirvelo in una o l'altra salsa, mentre il professor Capasso e gli altri oratori d'eccezione che parleranno oggi sono un'occasione unica che vogliamo sfruttare al meglio e desideriamo dare loro il maggior spazio possibile. Grazie.
To adapt in an ever-changing world, this is our task today. But now I can announce you a person who has done this for life. He studied at ETH Zurich, and he went to United Kingdom and then to Bell Labs in the United States. His topic, as we heard in Italian, was spin polarized electroscopy. Spectroscopy, yes, and it is Maurice Campagna, our president. He was always between research and economy because he decided to do more applied research, and he saved, in a way, ABB, which was Brown Boveri at the time. He built up the corporate research, and he was always linked to university and ETH Zurich. I'm happy to announce our president. The floor is yours.
Maybe I should show the very first slide for Federico. May I have the next slide? Well, first of all, I don't see very well all the audience, but I would like obviously to thank Alberto Petruzzella for his very nice words today and say that it is a great pleasure and an honor for me to see you today here in Lugano, in Trevano, and to enjoy together all this very nice presentation we're going to hear about, okay? If you agree, first of all, I would like to allow me to show one slide to say thank you very much to Enrico De Clever. Enrico, he's there, okay. The president of Balzan Foundation. It is fair to say that without President De Clever, without Enrico, we would not be here with Federico tonight and have this fantastic collaboration that has significantly improved in the last 2-3 years, especially with his dedication in order to strengthen what you see here, I would say, geographically separated from the north to the south of Europe, especially the north of south of Switzerland also, okay? With the Berner Alpen here seen from Bern, and Enrico very much helped us, showing up every time we needed in Bern to participate to the various events dealing with Balzan Stiftung, so Balzan Foundation. So thank you very much for coming today, Enrico, especially from Milano for this event. Now, to Federico Capasso. Obviously, I have to admit it is a special feeling for me tonight to present, to have this fantastic occasion to present Federico, because he started, in fact, a career, I would say, in a significant way in a place where I also had the chance to participate. But before that, he spent some time in a very important place, which is La Scuola di Fisica di Enrico Fermi, dove anche Enrico Fermi ha lavorato a Roma. He had very important teachers we have enjoyed together, also Franco Bassani, who was very active also at ETH in Zurich, Giovanni Iona Laisigno. He did not get really the Nobel Prize, but he deserved it actually with Nambu, frankly speaking. And then he had the chance to study with Francesco De Martini. He is the professor that spent a lot of time in the United States and brought actually the idea of ottica quantica to Italy, and he did the PhD with Martini. Now, it's very interesting for me because 1976, Federico managed with a grant from Rotary to join Bell Labs. He was a young student just after the PhD, and he was so good that right away he got member of staff of Bell Laboratories at that time. And he stayed there for 27 years, as we know, and he finally went through all these changes that very often happens in the United States with the restructuring also in research and in industry. And he was very successful, becoming vice president also of the current Lucent Laboratories in Murray Hill, New Jersey. Now, the question was, like for myself in '72, are you sure, Maurice, you want to climb the Everest of R&D, like it's meant to be the Bell Laboratories at the time? You know that the wind there is very icy and the air is very thin. Many of you know Bell Labs and they understand very well what I mean. Now, Bell Laboratories, as you know, is the cathedral. It used to be the cathedral in the 70s and 80s for research, and it's very famous because of the major discoveries that generated all what we use today, namely the integrated electronics, starting from the 47 transistor to something we're going to hear more about today, the laser, 1970, the more classical laser, you know, you based on atoms and molecules, and then to set basically the whole technology that we use for what is called the optical communications, fibers, amplifiers, speak recognitions, and so on and so forth. Now, it is very important to know that in the 70s at Bell Laboratories, when Federico was active, a very important technology was developed, and it's called molecular beam epitaxy. Most of you know what it is. I'm sure that Federico is going to tell us what is this molecular beam epitaxy. He collaborated very closely with a very nice colleague, Alfred Cho, and they developed what is called molecular beam epitaxy, the technique for integrated electronics using quantum wells. And this is the basis for what they then, to be able to show that this quantization is valid also for solid state in atoms and molecules. Federico in the 80s, as we are going to hear, developed MBE for stair-step heterostructure, who, 1994, allowed him to discover the quantum cascade laser, and I'm sure Pietro, Alberto, we are going to hear more precisely what is the quantum cascade laser from Federico today himself. Now, after these very important discoveries and development that they revolutionized basically the possibility of using lasers, Federico decided to join academia and went to a nice place up in Boston, Harvard. And Boston, again, is a very special place because you see that in contrast to what we know in many universities, and even ETH, Fritz Schisser of ETH Rat, president tonight, is here, is that they don't have departments. They just have a school. And these schools obviously allows to talk and to make interdisciplinary project in a very simple and unbureaucratic way. So he developed in this content new didactic methods. We are going to hear more about tomorrow in the session on digitization from Federico. And especially he had the ideas to develop what is called the flat optics, called bidimensional optical components. And in addition, he became, I would say, a more precise entrepreneur. Another interesting experience he's going to share tomorrow with us. Now, I've finished my presentation to make sure that you will have enough time to explain to us all what he has fantastically done in his life. Is that when they ask me, but who is really Federico Capassa? Well, Claudia Penzeller did have an interview in September last year when he came to Lugano to have an interlab with Balzan. And I suggest you can hear that in the web Digitale 21. But he tends to say, well, I am a designer. Federico is a designer of artificial man-made materials and quantum optical devices. Well, this is, I would say, for specialists, easy to understand, but otherwise it's a little bit more complicated. I would say I always tend to characterize Federico as a true scientist Federico has a feu sacré at all wavelengths. So he's really a feu sacré on the whole spectrum of communication. And Federico is very important. He is an inspiring and a reference for students and colleagues lifelong. So, Federico, we are very happy today to have you here. It's an honor and a pleasure to listen to you. Thank you very much. Do we have a laser pointer?
Do we have a laser pointer in the room? Otherwise, I have... Fantastic. Otherwise, I would have to wave my hands, which I look too much like an Italian, which I am, incidentally. Ok, good. Prima di tutto voglio ringraziare sentitamente Maurice Compagna, l'Accademia delle Scienze Svizzere, la Fondazione Balzan, che mi ha dato questo fantastico premio che non mi aspettavo assolutamente, l'USI e anche SUPSI. Adesso devo switchare alla mia lingua scientifica, che è l'inglese. Sono arrivato negli Stati Uniti a 26 anni per 9 mesi con una borsa Rotary, poi sono successe cose interessanti e mi hanno tenuto più a lungo. Quindi voglio parlarmi un po' della mia avventura scientifica che ho chiamato, let me switch to English, sorry, from quantum cascade laser to flat optics for the 21st century. Science doesn't happen without people. They are the main ingredient, I would say. Of course, you need some ideas and so forth, but if we professors do not have great students and great postdocs, we basically can't do anything at all. We just write proposals, and many of you who write proposals like me know this is not so exciting. So this is my current group here, very energized people, very creative. They're all smiling, so it means that they must be happy, right? So I want to step back. In 2015, the UN decided to call 2015 the International Year of Light and Light-Based Technology. And why? You see, optics, I didn't start in actual optics. I started particularly at Bell Labs doing solid-state physics, electronics, then I moved full force into optics. It is a discipline that is like a scientific platform. I challenge you to name me a field of science that doesn't use optics in some capacity. Even people that are doing computers and so forth, if you go to CERN, you'll see that in order to manage the extremely high data rates, okay, you have to use basically in the backplane of the computer optical interconnects. So light is everywhere. Yet Einstein said, you know, I still can't figure out what the quantum is, even though he's really the one with Planck that introduced the actual quantum. So there are, and this is the, Ban Ki-moon mentioned it very clearly in an actually beautiful speech, that it's really a cross-cutting discipline in the 21st century. I want to give you some quick examples of, the areas are, light technologies are in pollution monitoring. I will give you some examples. Now going to really high-tech, the so-called augmented reality is not quite there yet, but we know about virtual reality, and these technology use some pretty sophisticated optical components. Then you can go into the really quantum regime where you have atom-like system. You can put a single quantum structure into a crystal, and you can use it to do nanoscale magnetic resonance imaging, in vivo functional imaging. This is a very hot frontier. And of course, you know, the world of lighting and communication, and also, why not? It's so important, the connection with culture and art. My career started at Bell Labs as I started to have a discussion with Al Shaw. Al Shaw is the inventor of molecular beam epitaxy. Look, the technique is simple to explain. Now, to do it, it's another story. I mean, it needed the experimental genius of Al Shaw, it's like spray painting atoms on a surface. Consider that you have a crystal under vacuum, so basically there are no contaminants, and then you have cells that literally spray atoms of different elements. It could be gallium, it could be arsenic. In this case, you do gallium arsenide, a more complicated thing. And you can do practically layer by layer, atomic layer by atomic layer growth. So you can think now, this is the leap that several people made, is now I can alternate layers of different materials. And since the thickness is so small, in fact it is smaller than the wavelengths of the electrons in materials, you know that they behave both like particles and waves, so that we can really say that the electrons feel a novel material with new man-made properties. That's really the revolutionary aspect. So artificial man-made materials by design has enormous potential for science and technology. As soon as I started to collaborate with him, I said, oh, this is going to be endless. This is going to be so much fun. I felt like a kid, you know, playing with all these toys. You were just doing it for fun. But fun is an important component. It is a commercial system now, and it's made to make large amounts of different devices. For example, one of the most outstanding is the world's highest speed transistors, so-called bipolar transistors, are made by ultra high speed, are made by this MB and so forth. So I'm going to give you one example from my own research. I'm going to explain in a moment what a quantum cascade here. This is a quantum cascade layer, so it's a laser. It's made, you see, by multiple layers, okay? The thinnest layer is basically 5 angstrom. It's up here. And it's the alternation of 2 different materials. Black means one material, white one material. This is a cross-section obtained by high-resolution electron microscopy. So what happens is that I inject current from the top to the bottom here, and what happens is that the electron cascades down this staircase. It acts really, think of a step. An electron is like, not quite like a sphere because it is a wave, but it's also a particle light. At every step, it emits a photon. That's the central idea. And so you can see this is truly beautiful, the kind of things that you can do. And the key thing of this laser, this is the most important thing. You see, if I take a blue laser, now I say I want to make a green laser, there's only thing that you can do. Go to a different material, okay? Whereas here we showed with this new laser concept that by using the same combination of constituent materials, we could, and by changing just the layer thickness, we could change the laser wavelengths across the entire infrared region. The infrared is the region of invisible light, okay? It's invisible, but it's still very useful. At times can be dangerous when it is powerful and so forth. So that's the key point. And with this, we could target a region of the spectrum which until this moment, there were not really too many significant lasers. And so again, I'll be honest with you, you don't need to almost know physics at all to understand this. I create a step of, literally a step, and I'm going to descend. I have the electron going down this step. These steps here, this is energy. Because remember, when a particle goes down, a ball rolls down a series of actually steps, it gains energy. The same here. So this is a series of energy steps. This is distance inside the material. These steps have to engineer in a certain way so that they behave like artificial atoms. You can make artificial atoms with very discrete energy levels. So the energy level difference gives you the energy of the photon, which is the wavelength. So now to get this staircase, I need to apply a voltage. So I apply a voltage. So what happens is that electron gets in, for here at every step, the engineer, and that's the neat physics, it's a design using quantum mechanics. You can call this honestly quantum design. So at every step you can emit a laser photon. So if you have 20 steps, one electron creates 20 laser photons. These materials are semiconductors. Maybe I didn't say it before. Semiconductors is a material by which all chips are made, like silicon chips and so forth. There are already semiconductor lasers. Sure, the ones that send light in optical fibers are so-called near-infrared. They are based on an entirely different principle than this laser. And what this laser concept is particularly useful to target a region of the light spectrum where until now there was essentially no real significant source. And so I'm going to show you this, in fact. This is a spectral coverage of laser. You see, in the visible you have lots of lasers. In the near-infrared you have, in fact, the famous diode lasers used for communication, for white lighting, solid-state lighting. They gave a Nobel Prize for this development of solid-state lighting, extremely important. And in the mid-infrared, you see, until basically the Kronecker scale laser, there were very few good lasers. There was the CO2, carbon dioxide, very powerful, but it cannot be tuned. Our laser, the key point, you see, I put a continuous line. By engineering the material, we can get the entire wavelength coverage of the infrared from essentially a few micron up to 300 micron. 2 orders of magnitude of wavelengths. And moreover, given a particular laser, we have developed techniques to tune them. So I can actually tune the wavelengths of a particular laser. So that's basically the main point. And these lasers have found application in all kinds. There is a so-called molecular fingerprint region, okay? The molecular fingerprint here, because most molecules absorb light in this invisible region of the spectrum. And so this laser has started to flourish. There are now about, I can't count them anymore, but there are probably more than 35 companies. There are some big companies making this, like Hamamatsu Photonics, Thales, I think is still involved in it, Thor Labs, which is a major provider of laser components and so forth. And they have been used in all these things, process control in industry, the detection of explosive and hazardous gases, compliance testing, and this is still under development, breath analysis, but in my opinion, one of the most exciting. And finally, atmospheric chemistry. This is more the science, and this is, I'm pleased to say, I mean, my atmospheric chemist friends, and many are telling me these lasers are really changing the nature of the understanding also of the circulation, because you can do a fine-grained mapping of the greenhouse gases, and that can affect the modeling even of climate change. So you see, this is the spectrum application. Communication is developing for short term. This is the mid-infrared technology in general, okay? Of course, you use the mid-infrared imaging, thermal imaging. You can tell the temperature difference across a person. Security, industrial monitor. So I basically already mentioned this. Okay, the next is, well, this is an example of how you use a quantum cascade laser. So suppose you want to determine 1 part in a billion. I will even make it tougher, 1 part in a trillion in volume of a chemical. That's such a tiny amount that you have to use tricks. And the trick is very simple. It's been known for many years. Here is our laser, for example. In fact, other lasers as well. You have a cavity here where you put your chemical. Now, this is designed so that light bounces in and out, on left and right many times, so that the effective path, even if the cavity is only, let's say, 50 centimeters long, the effective path can be 70, 100 meters. This is important because if there is a tiny amount of chemical in a single pass, the attenuation, you see, you want to measure the attenuation of the laser in going through, is going to be negligible, very little. So by using multi-pass, we can detect even very small amount of chemicals, for example, down to parts per trillion. I think that's the record with our lasers. So people have had, this has expanded tremendously. The spectroscopy using quantum cascade laser. This is an experiment done by one of my collaborators, that's Professor Robert Curl, a very famous chemist. He was a co-winner of the Nobel Prize for the discovery of the famous buckyballs. But it turns out that was something he did on the actual side, which I told him, you know, this is great. If you manage to get a Nobel Prize for something you were doing on the side, that's really impressive. But his main activity has been doing spectroscopy. So this is a breath analysis, for example, of ammonia into the actual breath. Okay, so breath analysis, so here they were able to detect with this experiment 6 parts per billion of ammonia, 6 parts per billion in volume, which is really, this is developing. I'm not claiming it's there commercially yet, but I think it will happen. At least I've been talking to a number of doctors and so forth. I'll tell you of our development here. I asked the following question now. Suppose I make a quantum cascade laser which is designed for one wavelength. How can I make it, but I want to have a broadband laser. So the idea is I want to make a compact chip, a true chip, you know, sort of a couple of millimeter size. Compact is important for application, and I want to make sure that it emits only not one wavelength, but many wavelengths. So the idea was very simple. This was an engineering program, project, but it led to my first startup company. So we decided to make different lasers, different QCL laser, quantum cascade laser, each emitting a somewhat different wavelength. Then using off-the-shelf electronics, a microcontroller, we could send pulses to each laser in any sequence we want. So if we send it only here, we will get only one wavelength, but we could decide to ramp the signal and send current here, 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 or in fact simultaneously. If we do it simultaneously, we will get multiple wavelengths. So this is a tunable source. It led, and this is the actual chip, okay? And so these, you can see them, but they're about 30, I think 30 laser, 30 quantum cascade laser. Here are the electrical contacts. And now if I pulse, this is a pulse of actually current, I will get to one of these lasers, I will get this wavelengths and then this and the next. These are very pure wavelengths. I don't want to get into the technicality, okay? But there is no spurious wavelengths. These are truly, really single wavelength devices, and there is a trick to do it. I'm not going to go into it. So after this, we decided, you know, I never started an actual company. This happened at actual Harvard. You know, so I said, well, let's try. You know, it was so easy to start in the US, a company, that I regret right now that I didn't start before. Because as an Italian, I've always been terrorized by bureaucracy. I think that the Italians in this room understand. One of the main reasons I left Italy is I said, bureaucracy will kill me. I want to leave. It was one of my main motivations. And so when I said, you know, the paperwork we did literally in 1 hour, then we started to talk to venture capitalists. Nothing happened. We were 2 days from closing, that's it, until a donor, an acquaintance of mine mentioned, said, okay, Federico, I'll give you $500,000. That's it. That was enough to start. Then other money came in, and it's a pretty good story, because beginnings are hard. Now we did pretty well. Our company was, these are my co-founders. In fact, it's a Swiss citizen. Laurent Dio was a student of Professor Jérôme Feist, who actually played a critical role in the actual quantum cascade laser development and invention. And Christian Flugel from Vienna, Marc Vitinsky from the US is in atmospheric chemistry. So we form EOS Photonics, and then a few years later, a very successful Darius in Trappener, very famous Darius Vakshuri, who created also big companies, sold them, became wealthy, very open-minded. He says, guys, why don't you merge with Pendar? So Pendar Medical, we became Pendar Technology, so our goal is to, I'm one of the board members, chairman of the board, it doesn't mean much, actually, they have no power, but it's okay. That's how I get in touch, I stay in touch with the research. Bring into market breakthrough portable analysis and monitoring system through the fusion of innovative spectroscopy and science. I'm going to give you some examples of this. Our core sort of product is, we call it the Matchbox. You can see the size is very, very compact, actually. So it's basically the chip I showed you before, and the goal is to insert it in full sensor system. So one of the applications is this. This looks like a gun, but it's not a gun. Okay, essentially this is a device that has incorporated our chip. And if you want to analyze, for example, the chemicals on a natural surface, you get close to it, you turn on your laser, you look at the reflected light, and you can do security analysis. And this, there is indication there is a large market will actually develop in this area. This is important because if you have dangerous stuff on some surface, you don't want to go too close. So this is called standoff detection. Okay, standoff, where you stand a bit away from where the bad stuff is and use light to access it. Okay? Now I want to switch to climate change. This is, the situation is very serious. In fact, I'm telling you, I have been working with some of the world-leading atmospheric chemistry at Harvard in the last 10 years. And it's more serious. I don't want to scare anyone, but we have to say the actual truth. It's more serious than we think. That is told. Okay, and so that people still can deny that is just unthinkable. But you see, this is over here, in September, the ice reaches the minimum extension. This is well known. So this is how the minimum extension on ice. So the minimum in 2010 was here. Now, you know what it is last year? There was no ice anymore in September for a brief period. So that's scary. The acceleration has been tremendous of this. And this is the effect, of course, of global warming. You see, global warming is often presented as a temperature rising, but this is a bit misleading. Why is misleading? Because the temperature changes look so small that the average person says, who cares? There's a couple of degrees, and to go to this explanation, the thing that is dramatic is the feedback. You see, basically, because of the greenhouse gases, which trap essentially trap the heat, the infrared light, okay, the ice melts. As it melts, there is less reflectivity, less light is reflected back. So everything moves more. So there are these positive feedback that are accelerating quite dramatically. And now there is a problem not only in the North Pole, but in the South Pole, okay? And there are many feedbacks like this. So one colleague I collaborated with is Professor Steve Wofsy from Harvard. He did a beautiful study. He flew quantum cascade laser for 5 years from the South Pole to the North Pole. And in doing so, these planes, these are, by the way, the old U-2 plane. Remember when the Russians shot down the U-2? The young people don't know what I'm talking about, but the older ones know. In 1960, they shot down this plane, which was a spying plane. This was refurbished, and now it's used for science. So it went, in going north, it went from the troposphere to the stratosphere, 15 kilometers, measuring point by point greenhouse gases like methane, carbon dioxide, but other important ones, such as actually this and this is greenhouse gases. This is not a greenhouse gas, still very important. What is the importance of this study? It is the first fine-grained study of atmospheric chemicals. Fine-grained means spatially, right? With high sensitivity. This is basically the concentration measures Okay? And this is the precision. The precision is important. And this is very important because it just measure, so the precision, you see, a precision of 30 parts per billion with measurements of 300 parts per million. So these are truly exceptional studies from the point of the technique and the potential future impact. So they provide critical information for predicting climate change. By the way, I'm not a professor in this area. I'm a provider of laser, and I love to collaborate with these great people, okay? And so these are this is the system. There is a company called Aerodyne which has specialized in making this system with QCL. This is the famous multipass cell. You see light bounces up to, with a total length of, effective length of 76 meters. Yes, meters. But of course it's much shorter, right? And in this case, there are 2 lasers in this system here, and they can detect 3 chemicals, methane, N2O, CO, and you see the precision here. So, and this is exactly a complete set of measurement. What happens that the plane goes from the south, here the south, very south latitude. This is the altitude as it goes up. You can see in measure that this is a map. The color code is an actual concentration of CO and carbon dioxide. So as I said, these patterns provide new information about the location of emission ground has, and they're really the first one to provide a high-resolution section of the atmosphere that is critical for modeling. Okay, so this is how my other sort of, it's like a hobby, you know. My other great interest now, flat optics, started by getting at some point a great question from another leading atmospheric chemist, Jim Anderson. He's one of the creators of the Montreal Protocol to control the ozone hole. Instead of flying planes, he loves to fly drones. Drones, you can put them into, this is short, you know, they are maybe 1 meter long, and in places in the tundra where normal planes can't easily go. So we have been collaborating, in fact, with this since I was at Bell Labs. We gave him lasers. So, one day he said, Federico, I want to send one of my drones very high to detect high altitude clouds. I want to have one of your lasers here, and the light bounces, it's going to bounce first so I can get chemical information. But you know, there is a problem here. I don't want to use lenses. Why lenses are essential? Because you have to collimate light, because laser light diverges still. Okay, and quite a bit for quantum cascade lasers. He said, I want to have a very directed QCL, but I don't want to wear a lens. And I remember, since you are Fred, I think you are crazy, you know, but we'll try to think about it. But it was an incredibly good question. Can you eliminate the lens, you see? Because I have no space. There is a tiny space. So normally you would do this. Here's the laser. You put a lens in front. This is in the focus. You make it parallel, it's collimated, done. He says, I don't want this. So boom, I got together with one of my best students, Nanfang Yu, is now a professor at Columbia, and actually he had the key idea here. He said, you know, Federico, we should try to make some surface pattern here. So we put our brains together and really said, yeah, we want to make a contact lens for the laser. So without giving you the physics, I can tell you is, what we did is we patterned it with a small thin insulator and on top metal grooves. These are metal grooves. And what happened is the grooves, light that comes out here propagates along these grooves as a surface wave, and these provide a collimation effect, whereby the light now comes out highly collimated with a divergence of only a few degrees as opposed to 60 degrees. So that did the job, you say. So what happened? Was the experiment done? Well, you know, we wrote a proposal to actual NASA, and they said no, they didn't fund us. So it was never done. We are under control of the funding agencies. Okay, what can I say? This was a mistake. This was a very innovative study, but we still hope to do it in the future. But this then gave us the idea, now we can go into a new direction. Why do we have to, we don't have to make only contact lenses for the laser. This is a flat lens, you see, that's what's nice. The next thing, we said, why can't we make lens flat? You know, and this is the most recent work, in fact. Well, you see, the normal lens is okay. What happens, you need a sort of a curved surface to bend light. To bend light by phenomenon known since 16th century, Snell's law. Okay? The point is that this makes now, if you look at the focus, I've drawn it as nearly perfect, but it's not nearly perfect. What happens is that the rays that are out here, they don't get precisely focused, so the image gets blurred. Moreover, if you try with different wavelengths, it gets even more messy. So people have to stack multiple lenses. So the real so-called lenses of reasonable quality are multiple lenses. They are bulky and thin. So I still remember the conversation. So this is actually, the technology is so perfected that we forget what's at stake. Okay, here, how difficult, how expensive it is, okay? This is a machine, so you have multiple lenses here. You could have 6, 7, to correct all the distortion of light in the actual focus, right? And you need a special machine just to align them optically. This machine cost about $1 million. Now these companies are so good, Zeiss, so many other, Leica and others, that we tend to forget the complexity. So this is sort of the vision. What if now I can use planar or nearly flat lenses, and I can make the alignment much more easy, I can make the thing thinner, then maybe I can correct the aberrations better, and that's non-trivial. And so this is again, I'll tell you, so can we make a planar lens? So that's the idea. The idea is a classical example of nanotechnology. Molecular beam epitaxy is nanotechnology for other areas. So the simple idea is this. Can I make I start with a surface. I structure the surface with nanoscale feature, significantly smaller than the wavelengths. That's why I call this planar and or flat. So by structure with nanotechnology, so that all the rays converge to the same focus. The surface is nanostructure. These have been called metasurfaces, with maybe connection with metamaterials. Okay, you see the idea of how to do this is very simple conceptually. Okay, what you have to do is the following actually. What you have to do is, oh, Jesus, what I'm doing here. The idea is, you see, you have to think in terms of time. This wavelength. I want to make sure, if the lens is flat here, I want to make sure when are all the rays, these are the rays, converge here in a focus. It means that the rays must actually take the same time in going from here to here. If they arrive at different times, it's at least intuitive that the image is going to be blurred. Now you can ask yourself, this is impossible because this path is longer than here. That's where nanotechnology comes in. I can now, light enters here. If I can structure the material here so that light is delayed, is actually delayed much less, that it's delayed at this point here, okay, then the total time to arrive from here to here, from here to here, so I don't know what I'm doing. I just got off the plane, you know, maybe, but it's not jet lag, I don't have jet lag. Anyway, the time of arrival, so I engineer the total time of arrival from the center to here to be the same. It works. And you can write a simple equation, and you can just then make a nanostructure that does exactly what I said. And this is the technique, this is flipping, I don't know. Okay, the technique that we use, these are beautiful nanostructure made of titanium dioxide. These are pillars, you see, they're 600 nanometers tall. And the typical size, lateral size is the order of 50 to 60 nanometers. Now this is a metasurface. This is a detail of an actual lens, okay? What is the advantage of this material is state-of-the-art. You do not have to invent a new material. It has very low loss, meaning that you don't lose light by absorption. Look how perfect they are. One of these fell off. So it's vertical within a degree. which is very important. Now, we can do lots of things with the metasurface. You see, after this, we really, oh my, what we can do is the following. What if we don't want to focus light? What if we want to create strange light patterns? You see, depending on the arrangement of this nanostructure, I can structure light. In fact, there is a new field now called structured light. For example, this creates an optical vortex. So at the same time of the technology, we have created, done some fun new science. This creates a vortex of light. This is very simple to explain. It's explained in the next thing. So if I can make light to go in a spiral like this, what happens, if I put a camera in front, what am I going to see? I'm going to see a vortex. These are vortices of light created with our metasurfaces. This makes it exciting. I want to explain the spiral here. The spiral comes, if you do an interference experiment, if you interfere the vortex with the original beam, so you have a metasurface, you come with a regular laser beam, and the metasurface transforms the laser beam into an optical vortex. And we have done much weirder things, much weirder. It's a lot of fun. And some of this could be useful. Returning to the lens, last year, 2 years ago, we came out with this paper in Science, which was the first demonstration of these meta lenses. So we aim to have the same performance of the state-of-the-art objective in terms of resolution. So this is able to see details less than the wavelengths, limited by diffraction. And at this stage, I need to start a YouTube thing here. And I was told that this was all set up. Okay. It's 2 minutes.
Technology is shrinking. Smaller phones, smaller laptops, smaller everything. But shrinking lenses, like those found in cameras and microscopes, has been a problem. Material scientists are trying to replace glass lenses with something lighter and smaller, based on metasurfaces or engineered materials. In this metasurface lens, tiny towers of titanium dioxide are arranged in a specific pattern to focus light. Different patterns focus different colors of light. In a traditional microscope lens, the glass varies in thickness between the middle and edges. Inside the lens, the wavefront of light is shaped via different thicknesses of glass. This focuses the light at one specific point beyond the lens. In the metasurface lens, the transparent blocks also bend the light toward the focal point, matching what happens in the glass lens, but with much less material. The tiny metasurface lens building blocks, about 600 nanometers in length, can achieve the same resolution and magnification as a lens that is 5 to 6 centimeters in length. Fabrication of these meta lenses should also be much more cost-effective, compatible with silicon chip technology, versus complex polishing and sometimes stringent requirements for high-performance lenses. The next step is to focus all of the visible spectrum into the same focal length, using a metasurface lens. Once this happens, these glitter-sized lenses can replace the lens in a smartphone, regular camera, microscope, anywhere a lens might be needed, and the great shrinking can continue. Technology is shrinking.
Okay, good. Thank you. So you got, I think, that gives the whole story. This is a more recent lens here where we use cylindrical pillars. Again, these are highly reproducible process. I'm not going to go into details how we do this, but we use two processes. One is atomic layer deposition, which relates to MBE, and then second, lithographic technique to actually make this vertical structure. So now, let me show you the performance. If you look at the intensity in the focal lens, these lenses were designed for an optimum wavelength. The challenges in the last seconds of the video is to focus all the visible light in the same spot. So this lens, which was designed for the red, particularly, you see in the focus, we are diffraction limited when you see this pattern. So it sees essentially details down to half the wavelengths of light, okay? And the objective, and we compared it to a state-of-the-art objective, and you see we actually are comparable. I do not want to claim you better because these objectives are actually correct also for chromatic aberration. These objectives, all the wavelengths are designed to focus based in the same spot, but you can't do it really perfectly, so ours look better. The important thing, they are comparable. After this, the gates opened. The industrial interest was enormous, and I decided to start a second company. It was inevitable. I said, we've got to do something with this stuff. So at the beginning of this year, we reported the first broadband lens. This lens focuses light, all the wavelengths of the visible in the same spot here. The way we did it is actually, you know, the same concept than before, but it's more challenging. Now, I said before that every ray here, it enters from the back. In going to here must take the same time as any ray going from anywhere of the surface. Now, if you add the constraint, not only that all the wavelengths must do this, so they converge in here, then there's more sophisticated design, which we did. Happy to say it works. We reported it in Nature at the beginning of this year. So this is our achromatic meta lens. You see, basically, if you look at the spot size here, up to the red, essentially you are wavelength limited. You are close to lambda over half resolution. You are diffraction limited. If you look at a chromatic meta lens that does not have the correction for the different colors, you see, as you go increase the wavelength, the spot size tends to blow up, right? So we can also focus the whole white light into a single point, which is important. Now this, you know, this is very exciting because it's the most recent thing, collaboration with the Massachusetts General. All what I've shown before, if you want to be critical, you can say, have you really shown that you can do better than a real-world lens? Well, I would answer, no, but give me a break, you know. We only started this 2-3 years ago. It takes time, and that's true. But this is an example now. What happened, Professor Melissa Suter, who leads a group studying lung cancer, approached me and said, Federico, we are trying to make these bronchoscopes, and optically, when we want to detect lung cancer, so there's an optical fiber here, at the end we have a lens, and if we use a standard spherical ball lens, okay, which has spherical aberrations incidentally, or another type of lens which you also can buy, graded index, I'm not going to go into what it really means, I can't see the evidence of lung cancer because the spot size, you see, this is actually near the focal plane, okay? This is where the focal plane is. As you move near the focal plane, you see, this is really not good, not good. She says, can you help us? So my student designed a special metal lens to go at the end of the stethoscope. It worked the first time. You get images, focal points that you are diffraction limited here, much better. So this is an example we can do better than existing technology. In fact, she was thrilled because 2 days after she called me, says, Federico, I can't believe it. I can see, I'm not a doctor, so I'm not going to repeat everything she told me, but she said, you see this structure here? These are indication of lung cancer. They are on a scale of a micron, and now we can detect it, so we are probably going to develop jointly a new class of instruments. So I say this is a good example because we can do better than existing technology with our meta lenses. So what is the future? This technology is potentially game changes because it works in the visible, but it works also in the near infrared. As a place in all kinds of devices. Now the key point, and it was so in the movie, let me say it again. Now you have special companies that make the lenses in your cell phone. I'm going to pull it out. See, there is this bump here. This bump is bad. They don't like it. It makes also, they are thick. The vision is with our meta lenses, the camera module, okay, the lenses will be made by the same technology that people use to make chips. So this camera module has a silicon chip, it's called CMOS sensor. On top, they're going to be our lenses made by the same company. They will revolutionize the actual business model. And I'm telling you, this is not because I'm saying it, that would count for nothing, but because I've been speaking to many companies. So we'll be on a large scale, small fraction of the cost by the same founders that mass-produced microprocessor. And in fact, recently, one of my students went up to the Cornell facility and using the same tool used to make integrated circuits, was able to make a 2-centimeter diameter lens, which is quite significant. So the applications are many. I didn't add the functionality, the fact that in the future these lenses also can be used for, we have made lenses that for one wavelength behave like a lens, and for another wavelength they behave like a totally different device that creates a certain light beam. So they can be multifunctional. And so, you know what we did? We started a company with an experienced entrepreneur, Bart Riley, former student of mine, myself. The good thing, we are called Metalens. We have major support by venture capital. And no exaggeration, we have some of the biggest industries that are around now, biggest company, they are supporting us. So we are very excited. I think we can revolutionize truly not only the way lenses are made, but the business model by which essentially lens molding, in my opinion, in the long run will actually disappear. Okay? Of course, it has to be shown. I want to go back to the point of optics. You know, I hope I've given you with this an idea. 2 years ago, an extraordinary thing happened. The detection of gravitational waves as predicted by Einstein. Essentially, scientists thought you can call it the cosmic union of two black holes spinning around each other, creating gravitational waves. What was not emphasized, and it's too bad, there was truly extraordinary optical technology to make this possible. I want to give you a feeling again of the impact of optics, if you like, in theoretical physics, in astrophysics. What happens is they made an interferometer, light travels here, and what happens is gravitational wave, you see, in one direction they compress space, in the other direction they stretch it. So when a gravitational wave around, this is slightly shorter than this. So you can pick up that optic. This is what is extraordinary. The interferometer detects changes in difference between the two arms as small as 1/10,000th of the proton size. It's mind-boggling. This is what optics can do now. And of course, there's a wonderful mechanics, so it's really, I think, important, never separate the engineering from the physics, from the science. They go together. And hopefully we'll have a better society in the future, even with all the things happening now. Anyway, thank you very much for your attention.
Thank you so much, Mr. Campasso, for showing us so well the effect of science and on society, on economy, on the globe. And we brought you a knife.
Thank you. Maybe I'll
There is not a flatland yet. You can put it in a baggage, not in a hand luggage. But maybe in some years it's something really rare because it has a bent lens. And Maurice Campagna will now moderate the questions.
Yeah, thank you very much. I think he deserves another applause. It was really fantastic. You agree with me that the presentation was fascinating and extremely motivating in an area, I mean, optics that is learned from high school to ETH Zurich, yeah, and it demonstrated what new technology together with physics and engineering can do to revolutionize what we thought it will be forever the same, you know, big company like Zeiss and so on we heard about. Especially, obviously, you can see that what people are saying very often, you know, what are these disruptive technologies coming along? Here we have a fantastic example of how, you know, certain needs like cameras and so on and so forth are obviously demonstrating that major changes, major business changes are going to being seen on the front of the horizon. So, and what is fantastic especially is these things that you mentioned at the end, that many of the fantastic recognitions like gravitational wave issues at the end, they have not really recognized that it is because of the fantastic contribution of optics that allows to be so precise, because it is something very, very, very difficult if you're not really a physicist to understand what it means, this 10 to the minus 17 or something like that. It's really, really incredible. Now, I think it was especially interesting also to hear about, you know, we always kind of skeptical about global change and is it 2 degrees warmer, 3 degrees warmer, especially somebody from Ticino says, well, it is pretty cold, in fact, in April, okay? So what the hell is this warm? But he explained it to us really that and this was something I learned today very clearly, the importance of the feedback because you have less reflectivity.
Yeah.
I mean,
yeah, if I may say that,
right.
There is another very important feedback. In the tundra, there are tons, teratons of methane that are trapped in clathrates, which are chemical compounds, and in other forms. As things warm up the tundra, there is more methane. So my collaborator Jim Anderson has been able to detect with quantum cascade laser more and more methane. So at some point could be, I don't want to exaggerate, but a very bad scenario that there could be a sudden release of actual methane. It's a nonlinear process, hard to predict. That's another example of feedback, and there are many others. So there should be more emphasis on feedback rather than simply the temperature raising.
Yes. Now, I obviously took up myself a lot of time. I wonder whether there is some immediate question, some wish that you have on what Federico Capasso presented so spontaneously in his fascinating and very broad talk with this unique opportunity we have to listen to, have to share his lifelong experience in this context. Well, Federico in any case is going to be around tomorrow. Federico domani parteciperà di nuovo al nostro simposio Digitale 21, metterà a disposizione la sua esperienza in particolare per quanto concerne non solo la tecnologia, ma anche per quanto concerne la sua esperienza nei nuovi modelli di insegnamento, che logicamente è una cosa estremamente importante se pensiamo a quello che capita anche all'ETH Zurich o all'ETH di Lausanne, alle università, SUPS, eccetera, con tutti questi corsi, mass online courses, eccetera, eccetera. Quindi siamo interessati in modo particolare di sentire la tua esperienza anche in questo campo domani pomeriggio e di in particolare condividerla con gli studenti che provengono da tutta la Svizzera. So I think we are basically on time, and I would say thank you very much again for your very nice motivating experience. We are going to share with you tonight down again. Enjoy the time. Thank you very much, Federico. Thank you. So I think, Claudia, we can at this moment actually continue with our second part of our afternoon. Before that, our foreign minister shows up. He's coming from Zurich tonight, Ignazio Cassis, and he promised to be here on time. We're going to see whether he's going to make it or not. In the meantime, we have some speeches ahead of us with Rudolf Minch, and so on and so forth, and also a short message from ETH Zurich, our president, Fritz Schießer, and finally Monica Duca-Wittmann. So the floor is yours again, Claudia. Thank you.
Thank you very much. I'm very happy to announce you Laura Perret-Ducommun, who is the Secretary General of the Swiss Trade Union. She has a PhD in computational science and a degree in higher education. She has experience also in policy making because she worked at the Swiss State Secretariat of Education, Research and Innovation and at the Swiss Federal Office of Statistics. And we are really happy to have her here from Swiss Romande, and she will speak to us in French, and you will see the slides in German. Thank you very much for being with us.
Mesdames et messieurs, bonsoir. Je vous remercie beaucoup pour cette invitation. Ça me fait très plaisir d'être avec vous aujourd'hui et de prendre un petit peu de distance et de perspective par rapport à la Berne fédérale. Je dois avouer que d'intervenir après Federico Capasso, c'est un défi. Je ne peux pas faire beaucoup de liens avec lui, même si je viens du domaine scientifique. Il y en a juste un que je peux faire avec un autre passionné du laser à cascade quantique, Jérôme Feist, puisque j'ai étudié à l'université de Neuchâtel dans les années 90, où il venait d'être nommé jeune professeur de physique. Je crois qu'à présent, il est à l'ETH, mais c'est le lien que je peux faire. Et ça me rappelle d'ailleurs une petite anecdote que j'aimerais partager avec vous. Pardon. Voilà. Ça me rappelle une anecdote que j'aimerais partager avec vous. Dans les années 90, quand je faisais mes études, je travaillais en parallèle pour les financer dans une petite entreprise privée de services ou de conseils en informatique. Et puis un jour, j'ai eu un mandat un peu particulier. Et le mandat, c'était de former une secrétaire de direction qui avait environ 50 ans, qui avait quitté le monde professionnel pour s'occuper de ses enfants et qui venait de retrouver un poste de travail. Elle devait être formée. Simplement, il s'était passé 15 à 20 ans pendant cette pause. Et donc, quand elle avait quitté le monde professionnel, elle utilisait encore une machine à écrire. Et à la fin des années 90, quand elle est revenue dans le monde professionnel, on était passé à l'informatique, à Internet. Donc, il y avait un certain gap à combler. Alors, j'ai accepté avec enthousiasme cette mission de formation. Et quand elle est arrivée, c'était très intéressant parce qu'on a commencé donc, par utiliser un ordinateur. La mission, c'était que je la forme à l'informatique de base, l'utilisation d'un ordinateur et puis des outils Office, Word, Excel, etc. Et puis ce qui est intéressant, c'est que le premier défi qu'on a eu, c'était la manipulation de la souris. Parce qu'elle n'avait jamais vu une souris d'ordinateur de sa vie. Et donc la première chose, c'était de comprendre le lien entre la souris physique et puis le curseur sur l'écran. Ensuite, de pouvoir la déplacer. Et puis, à un moment donné, la déplacer la souris jusqu'au bord de la table. Et là, c'était le blocage. Je veux dire, mais comment je fais maintenant? La souris, elle va tomber par terre. Donc, ce n'était pas vraiment intuitif, l'utilisation d'une souris. Et puis ensuite, quand elle a continué à manipuler cette chose étrange, quand il fallait déplacer des objets sur l'écran, elle était tellement crispée avec cette souris dans les mains qu'à chaque fois qu'elle essayait de toucher un fichier ou un dossier, sa main partait, le fichier, le dossier disparaissait n'importe où sur l'écran. Donc on a fait une journée. La première partie, ça a été de se familiariser avec un ordinateur, avec une souris, avec les manipulations de base, de dépasser certaines peurs, certaines résistances, pour ensuite pouvoir rentrer plus concrètement dans les outils informatiques qu'on devait utiliser. À l'autre extrémité, j'ai 2 enfants. Le plus grand, il a 6 ans. Et puis, il a réussi à déverrouiller mon iPhone quand il avait 1 an et demi. Alors ça donne un petit peu les 2 extrêmes. Et pourquoi je vous parle de ça? Simplement parce que le plus important de mon point de vue, c'est l'être humain, dans le contexte de la numérisation. Et donc, pour la présentation que je fais aujourd'hui, je vais prendre une autre perspective que mon activité principale qui est dans la politique de la formation. J'aurai l'occasion de parler de la politique de la formation demain après-midi dans la session 4. Mais là, je vais plutôt intervenir avec une autre casquette qui est une casquette de coach professionnel et m'intéresser davantage à la dimension humaine que systémique. Alors, vous connaissez tous ces géants du web, GAFAM, comme on les appelle en français, Google, Amazon, Facebook, Apple, Microsoft, leurs équivalents chinois. D'ailleurs, si vous suivez l'actualité, ce serait difficile de passer à côté du scandale de Facebook par rapport à l'utilisation des données par Cambridge Analytica pour l'élection de Trump. On constate aussi une augmentation de la productivité lorsqu'on utilise ces outils. Ils n'ont pas que des effets négatifs, naturellement. La différence générationnelle apparaît beaucoup dans l'utilisation de ces outils et dans la digitalisation. Les baby-boomers, entre 45 et 65, la génération X, dont je fais partie, qui sont nés entre 1965 et 1980, la génération Y, née entre 1980 et 2000, et la génération Z, née après les années 2000. D'ailleurs, ce qui est intéressant, quand on regarde dans les débats en politique sur les travailleurs âgés, les avis divergent sur l'âge. À l'époque, on parlait de travailleurs âgés à 55 ans, 60 ans. Ensuite, on est descendu à 50 ans. Maintenant, les travailleurs âgés, c'est à partir de 45 ans. Et si par hasard, vous êtes dans le domaine IT, alors à 30 ans, vous êtes déjà has-been. Ça devient assez compliqué de se maintenir dans le marché du travail et de faire face à ces défis aujourd'hui. Il y a quand même des éléments inquiétants, des dérives et une part de déshumanisation rampante avec cette digitalisation. Dans les dérives, ce qu'on peut dire, c'est qu'il y a beaucoup de peur, beaucoup de résistance et de barrières, et aussi de l'isolement. Donc une numérisation qui est mal contrôlée, pour laquelle personne ne se sent vraiment responsable, met en danger notre sentiment d'identité, notre sentiment d'humanité. Il devient difficile de séparer la vie privée et la vie professionnelle quand on regarde le home office, les différents horaires, les outils où on peut être disponible et atteignable n'importe où, n'importe quand. On est asservi aussi par les outils numériques, les robots qui définissent par exemple l'agencement de notre journée de travail. On constate aussi une perte de l'intelligence collective qui est créée avant tout par les interactions humaines et sociales, qu'on a un risque de perte de capital social. À l'avenir, on vivra peut-être jusqu'à 120 ans ou plus en ayant remplacé une partie de notre corps grâce à la technologie, mais finalement, quelle part d'humanité il nous restera dans ce transhumanisme avec des êtres humains augmentés? Alors, je fais juste un petit zoom. L'être humain crée ses représentations mentales, notamment grâce à ses sens, la vision, l'audition, le toucher, l'olfaction et le goût, et ces représentations façonnent nos émotions. Malheureusement, la numérisation et la digitalisation altèrent ces perceptions et affectent aussi la création de nos représentations mentales. Ça influence aussi nos valeurs et nos croyances qui déterminent la manière dont on se perçoit. Pour prendre un exemple très concret, le toucher, on sait très bien que des enfants qui sont privés de toucher développent des troubles du développement, des troubles du comportement. Les personnes âgées, lorsqu'elles sont isolées, qu'elles sont privées de contact social, éprouvent une souffrance psychologique. Donc le toucher, c'est quelque chose de très important, comme ce qui est favorisé justement par les interactions humaines et sociales et qui a tendance à se perdre avec les réalités virtuelles et les relations virtuelles. On peut se poser la question quelle perception on aura de nous-mêmes lorsque 80% de notre corps sera artificiel et que nous serons en relation virtuelle avec d'autres individus, voire des robots. Face à cette situation, la numérisation est intéressante seulement si elle est au service de notre humanité. Et qu'est-ce qui fait notre humanité? Notre conscience, notre désir aussi, qui est notre principal moteur d'évolution, et notre libre arbitre. Alors il y a des corrections à apporter au système, et notamment aussi de prendre en compte la dimension individuelle. Alors essayons de remettre l'église au milieu du village et nous interroger sur certains éléments. Comment est-ce que la numérisation peut être mise au service de la société plutôt que de constituer un danger pour elle? Comment nous reconnecter à notre humanité grâce à la numérisation? Comment éviter les dérives? Et comment accompagner les personnes dans cette transition et dans les défis qui lui sont liés? Et quels sont les métiers de demain qui aideront, qui faciliteront cet accompagnement? Alors, je ne prétends pas avoir la réponse à toutes les questions, mais juste quelques pistes de réflexion. Du point de vue de l'individu, il est fondamental d'accompagner les gens dans la transition. Et il y a beaucoup de métiers d'accompagnement qui existent ou qui se créent ou qui prennent de l'importance dans le domaine du coaching, dans le conseil. Si je me rappelle de cette femme de 50 ans que j'ai formée il y a une vingtaine d'années, elle n'avait pas des problèmes de compétences techniques. Elle était très intelligente, très smart. La compétence technique, elle est venue très vite. Les difficultés qu'elle avait, c'était des peurs, des résistances. Et ce dont elle avait besoin, ce n'était pas des outils, c'était d'être entendue, rassurée, écoutée, valorisée, encouragée. Si je regarde le système de formation, Le système de formation, on doit davantage s'orienter vers la formation continue tout au long de la vie. On a aujourd'hui un système de formation qui est segmenté. On a la formation générale, académique, la formation professionnelle, on a le degré primaire, secondaire 1, secondaire 2, tertiaire, formation continue, c'est très segmenté, très organisé. Mais on va de plus en plus vers un continuum puisqu'on va changer de profession, de métier 4, 5, 6 fois dans sa vie. Et on devra obligatoirement acquérir de nouvelles compétences, se réorienter, faire un métier qui peut-être aujourd'hui n'est même pas imaginable et qui dans 20 ans sera juste une évidence. Et donc, à mon avis, il faut sortir de cette logique qui est très structurée, segmentée pour aller dans une logique un peu différente. Pareil pour l'orientation professionnelle. On oriente les jeunes quand ils sont dans la scolarité obligatoire sur leur choix de profession, mais ça ne s'arrête pas à 15 ans ou à 18 ans. Ça continue pendant toute sa carrière professionnelle jusqu'à, voire même à la fin de la carrière professionnelle. Ce qui me paraît aussi important, c'est d'inclure aussi les contenus sur l'éthique, parce qu'on a beau avoir de nombreux outils à disposition, il y a des questions éthiques et morales qui se posent. Et enfin, ça c'est plus dans les outils, de favoriser le blended learning, la combinaison entre l'enseignement online et présentiel. Du point de vue de l'économie, mon collègue Rudolf Minch en parlera certainement juste après, mais de mon point de vue, il y a des choses à faire au niveau de l'organisation du travail et de tirer profit, bien sûr, des nouvelles possibilités. Mais c'est aussi important de se rappeler que c'est des êtres humains qui sont dans ce système, qu'il faut favoriser la conciliation de la vie professionnelle, privée, de la mobilité. Quand on se retrouve à devoir changer de métier à 40, à 45 ans, qu'on a une famille, des enfants, des obligations financières, ce n'est pas toujours évident de réussir à concilier une nouvelle formation avec son activité professionnelle, avec son activité privée et sa famille. Il y a aussi des questions de protection, protéger des gens, protéger la sphère privée, améliorer la séparation entre la vie professionnelle et la vie privée. Aujourd'hui, à l'extrême, parfois des gens vous envoient des emails le samedi soir à 22h, et si vous n'avez pas répondu à 22h15, ils sont fâchés. Il y a quand même certaines limites, probablement, à introduire. Et puis, au niveau de la société, je pense qu'il est temps de mener des débats de société sur les conséquences de la numérisation, sur l'avenir. Peut-être créer un conseil éthique mondial qui se préoccupe de ces questions-là, prendre des options politiques pour éviter justement des dérives et servir l'humanité. Et c'est là que je pense que l'Académie suisse des sciences a un rôle important à jouer, de par sa mission de dialogue entre la science et la société et les conseils qu'elle prodigue aux politiques. Voilà, j'en ai terminé pour cette première perspective et je vous remercie de votre attention.
Thank you very much for this food for reflection. This is food for you. But we will certainly have to discuss a lot, and tomorrow in the breakout session we will have the possibility. It's always a trade-off. I educated 3 children, and only because I have the internet at home and was disposable to work also after dinner and at night and up to midnight, I'm now here as a professional and I don't have to learn how a computer works. So it will be a trade-off and it will be discussed, and thank you very much to give us these impulses. And now I can announce you a man who asked, are we ready for the future? It's Rudolf Minch. He is the chief economist of Economy Suisse and the leader of the Department of Economy and Education. At the same time, he is still a lecturer at the Executive School of the University of St. Gallen, and he does a lot of applied research on economics in different fields. The floor is yours, Rudolf Minch.
Good afternoon, ladies and gentlemen. It's a huge pleasure to have some minutes to share some thoughts with you about this digitalization process. And because time is somewhat limited, I would like to start now and ask the question, are we ready for the future? Meaning not what is me, we is Switzerland. In my point of view, is Switzerland ready for the future? And I try to answer at least give you some hints about these three different questions. Is the digital revolution a job killer? Is this a threat for us, or is it more a chance? What the policymakers should react to maintain the jobs in Switzerland. And the third one is then, is Switzerland, in a sense, ready for this whole process, for this digital revolution that really shapes our world? And then I would end up with some not economic view, but more about the Swiss DNA. Is the Swiss DNA compatible with this digital development? You all know about these 4 steps about this industrial revolution, starting from the steam engine, then the mass production, then the electronic equipment, and meanwhile we have the networks of different things, this Internet of Things and these networks. The question is then, what was the result of the first 3 revolutions, industrial revolutions? Higher wages, more leisure time, better rights for employees, low unemployment rate, better health, better lifestyle, more freedom, a wonderful world. The question is then, is this time different? And we have some difference between the first 3 industrial revolutions to this one. It's more, the service sector is more affected, much more than it used to be in the first 3 revolutionary phase. We have these disruptive evolutions and a bunch of new products you're all aware about. So is it a threat for jobs? And there are many studies. Economists love to do studies about the future. Even nobody really knows what happens in the future, but at least some authors has tried to give an answer to this question, and they say, oh, 47% of all jobs are under threat. Was this out from Frey and Osborne, and then from the OSCE, Arndt et al. Has presented a new study, and they say, yeah, it's just about 9%, and other studies came to similar conclusion, about 10%, and so what we do not know really what happens with our jobs. But it's a clear asymmetry between, we know pretty much what's going on, which job can be replaced by robots. But we have no clue about which jobs will be created in the future. So there's a clear asymmetry, and by the end, it will be probably about the same as it used to be in the first 3 industrial revolutions. It has created much more jobs than it has destroyed. Do you know how many jobs are lost every year in Switzerland? Around 10% of every job is replaced by the end of the year. About 10%. So 10% are cuts, but 10% are built from anew. And as a result of that, this is the number of million of employees in Switzerland in the last 130 years. And you see there is no influence of technologies on the number of jobs. And probably this could be a good forecast for the future. Why should it be totally different this time? However, it will not be that easy, and it has been mentioned before. The qualification level will increase. This is a slide from the past, the number of jobs lost in Japan, EU, and the USA. And here you see clearly high skilled jobs has been created from anew, and a lot of routine jobs has gone down the river. And these development will probably go on for the next decades. A lot of routine jobs will be replaced by robots, by computers, and so on. So what kind of competence should the people have? And also this is, again, the same question. It's related to the future and therefore quite difficult. The World Economic Forum has asked the manager, what do you think about that? What will be important in a couple of years, in 2020? And they say, and this is the most important thing, complex problem solving is the most important things people should do. And social skills are of great, great importance. And when we talk about digitalization, probably it's often forgotten that this is one of the most important things. Social skills are of that high importance. So what competences will be demanded in the future? Here, a thesis. The future workforce should have different competences as they have today, expertise, decision-making and responsibility, self-competences, but also a lot of social competences. And the STEM, science, technology, engineering, math, will become more important for a broad range of jobs. Soft skills are becoming more important, and this leads to the need that the workforce will be relatively mobile and flexible, change jobs every now and then or every couple of years, and the meaning, the importance of lifelong learning. So policy recommendation is one simple thing: education, education, and education. So back to the question, are we ready for the future? Switzerland, the obvious factors, most competitive country, leading universities, most innovative country in the world, also quite ready for digitalization. Here, Switzerland is only ranked number 7th, but it's not so bad. So we can say we have pretty good prerequisites in Switzerland. An excellent academia, this dual education system that fits perfectly to the working force, to the labor market. And something as an economist, we can often not say it towards our enterprises, but the high price level in Switzerland has also a positive side. The high price level force in the industry to be highly productive. So all these mass production, labor-intensive jobs in the industry are already gone. So this makes Switzerland much less vulnerable than other countries. So we can say, yes, Switzerland, yeah, in a sense, obvious factors are quite good. Let's have this question in a more deeper detail. Do you remember the 15th January 2015? So the drop in the exchange rates, the sharp appreciation of the Swiss franc overnight. Then what we have observed, these are the export volumes. And you see, when you have a good eye, in 2015 there was some reduction in the export volume of the Swiss industry. Yes, it was, but far from being a dramatic impact of the exchange rate appreciation. Why has the economy performed that well under this stress situation? And there are a couple of reasons, and some of them I've given you already, these obvious factors. But one thing which is extremely important, we have a quite flexible labor market. Layoffs are possible. Enterprises can react in a stress situation. And the second reason is entrepreneurs take on the challenges. Suppose the same situation has occurred in France, in Germany, or in Austria, probably the enterprises would have directed their question towards the politics. Please help us, we have an extremely difficult situation. Help us Paris, help us Berlin, help us Vienna. In Switzerland, nobody believes that Bern can help you. So the enterprises did on the challenges, And this is somewhat like the soft factors I have started to communicate. Soft factors, I believe, play a crucial role. And this is an attempt to formulate the Swiss DNA. I know it's not really science-based, but we have some sayings in Switzerland, and 3 sayings are pretty good to draw this picture. Anyone can make it. We have close to no aristocracy in Switzerland, no class thinking, or close to no class thinking. So everybody can make it. Where he has grown up, what education he has started in, it doesn't play a role. You can make it in Switzerland. And God helps themselves, who helps themselves, personal responsibility, but also some sense of community. And focus on performance, strong performance, but equal opportunities. The low tuition fees at the university is a sign of that. And it's never too late. Education is always possible to go on. I've talked now a lot of positive things about Switzerland. However, there are some but. The not invented here syndrome in Switzerland is all around. When we talk to each other, where you're from, you know, we're from a canton or from a region, but Swiss, we are only abroad. Probably it should be a good thing to work better to make this synergy happen in Switzerland. We are so small, and we could really make more of these synergies, networks, and also not only between universities, yet networks, but also between universities of applied sciences, universities, and the business side. This will create a lot of positive things. And I have a second but. And this is, the richer we are, the more we can lose. Economist tells you this is some loss aversion. Yet the richer we are, the more is the tendency towards the status quo. We want to maintain Switzerland as it used to be in the last 20 years. Forget that for 20 years the life was not that good as it is nowadays, but anyhow, we want to conserve our tiny and lovely country. And this is probably not the best prerequisite for the digitalization and for the readiness for the future. I have a picture here from the parliament. In the middle there's the Stimmbevölkerung, the voting population, between left and right, between progressive and between conservative. And you see what happens in the last couple of years with the parliaments. The parliamentarians are going towards becoming more similar like the voting population, becoming more conservative, less liberal, less progressive. And this is a sign, as I said before, to maintaining the status quo in Switzerland. So my question is, or the big question is, I think, do we believe in the future? Do we really believe that tomorrow will be a better world than we have nowadays? That we don't have to preserve all what is around, that we are going towards a brighter world in the next decades. So, the Swiss DNA is compatible with the digital development, yes. The prerequisites are good. We have to improve our business conditions, yes. But no industry policy is necessary. We have to invest a lot in research and education. And please help to convince our fellow citizens that the pros of the digitalization are huge and the future is bright. And also work together. Thank you a lot for your attention.
Preconditions for digitalization are realized here. We are here with USI, SUPSI, EUFFP, with ETH, with everybody, so maybe let's work together, and thank you very much. And now I have the honor to introduce Mr. Fritz Schiesser. He was a member of the parliament, and he was even the president of the Council of States, and he heads the ETH-Rat as the president of the board, and he is active in different organizations in innovation, research, and education, and we are happy to have you here. Fritz Schiesser, the floor is yours.
Egregio signor Presidente, gentili signore, egregi signori, è un grande piacere essere qui a Lugano, in Ticino, alla Digitale 21. Mille grazie a Maurice Campagna e alle Accademie Svizzere delle Scienze per l'invito. Penso che il Ticino sia un luogo eccellente per una conferenza sulla digitalizzazione nel settore dell'educazione, della ricerca e dell'innovazione. Proprio nel mese di febbraio il BAC Economics Basilea ha pubblicato uno studio che mostra che il Ticino ha una crescita economica più alta rispetto al resto della Svizzera. Nel periodo 2017 a 2025, secondo BAC Basilea, il settore delle tecnologie informatiche dovrebbe crescere più di tutti gli altri e i politecnici federali vogliono contribuire a questa crescita. Soltanto a 100 metri da qui si trova il Centro Svizzero di Calcolo Scientifico con il suo supercomputer Pitstein, dove attualmente 1200 scienziati lavorano a 120 progetti. I have been invited to say a few words about the item from research to innovation. Digitalization and its influence on science and research is an important topic. Digitalization is driven by technology, an area in which the Federal Institutes of Technology are, of course, heavily involved. There are 6 institutes, the 2 schools, and the 4 research labs. In the background, you can see the 6 institutions of the ETH domain. The ETH board has defined Okay, thank you very much. The ETH board has defined 4 strategic focus areas for the period from 2017 to 2020. We have chosen them because they cover subjects, areas important for Switzerland. And as you see, they have close links with digital technologies. One of them is energy, which has been a focus area of many years. One of the aims of data science, another focus area, is, of course, to learn how to handle huge amounts of data. Another focus area is advanced manufacturing, aims to bring digital opportunities into industrial production methods. These include 3D printers and new manufacturing technologies. The focus area, personalized health and related technologies, aims to gather and analyze large numbers and large amounts of health-related data so that individual patients can receive customized treatment in the future. The ETH domain sees it as important that this cutting-edge research spread into Switzerland's economy and society. Naturally, we want Ticino to benefit from supercomputers, and we want to contribute to making information technology the strongest growth sector in this canton. As you can see, we currently have around 3,200 corporations, ventures with the economy all over the country and abroad. And if we take a look at patients and spin-offs, you can see that we are launching a new spin-off practically every week. I believe we need to get this message across to the politicians too. Investment in education, research and innovation brings prosperity and jobs. And we heard it before from Rudolf Minch. Switzerland is one of the most innovative countries in the world, but we have the challenge to keep this position, and we are jeopardized to get surpassed by other countries. One important contributory factor is our excellent system of education and research. Let's take best care of it. Thank you very much for your full support and for your attention.
It's good to hear that we have a chance and we have good researchers and we have good material for discussion tomorrow. Thank you very much.
Thank you very much.
And now I have the pleasure to announce another musical interview by the saxophone quartet of the Conservatorio della Svizzera Italiana. Enjoy. Thank you very much for this beautiful music. Let me just check. I heard, and with digitalization it's possible to inquire. I heard that Bundesrat Ignazio Cassis arrived. Good morning. He landed, scusi. I had two calls. Maybe we play another piece of music. I heard he is really close. He landed well in Anja, and I had an SMS saying he is really close. So let's have a look. Ok, tante grazie. Ho sentito che il consigliere federale è arrivato sul parcheggio, allora si tratta di qualche minuto. E poi c'era un viaggio alle 17 ha preso l'aereo per arrivarci, per farselo, perché aveva un appuntamento urgente che non era pianificato, allora fa veramente tutto per noi. Forse qualcuno di voi ha una domanda? Perché abbiamo 2-3 minuti per discutere prima di avere con noi il nostro ospite di onore. Niente domande? Ci sono alla Casa delle Accademie ho un collaboratore che ha sempre una idea per una domanda e posso essere sicuro, sfortunatamente non c'è. Però forse c'è un'altra persona che voleva sapere qualcosa su quello che abbiamo sentito. Morris, non hai una? Ah, Antonietta Mira, mi salva.
Grazie. In realtà era una domanda per il professor Capasso, quindi ancora con riferimento alla relazione Balzan. Mi chiedevo, in quanto nella vostra ricerca, in your research, how much is it real experiment and how much is it computational experiments and how much is it data analysis? Thank you.
Antonietta Mira è una professoressa per data science.
Yeah. Yeah, we actually met in Lugano, right? Yes, we are an experimental group, and in reality today you cannot just do experiments. So every student, postdoc, has to do. It's not that I tell them has to do. Their project involves design. The design is both at the level of the physics, because we design the physics also, meaning, you know, we design new material, new structure. There is a design part, there is a fabrication part, and so part of the design involves a lot of computation. And we do a lot of electromagnetic computation, but I'll say something at the end. We do fabrication, we do experiments, so we do the whole cycle. And now we are going into, I have started a former student of mine who is thinking about machine learning, most sophisticated thing. Inverse design. I mean, in our design, we typically go forward. We have an intuition, and then we actually calculate, but inverse design is the actual following thing. I want to create a structure that generates a certain light beam or a certain function. So you now work backwards by putting some constraints. So this is more complex, but far more powerful way to calculate. So we are more and more deeper into computation also.
Thank you very much.
I obviously had one question.
Oh, okay. That's wonderful.
And to Mr. Minch, maybe I start with Federico. The question is related to what about extending your applications to even further lower wavelengths, you know, in the area of gigahertz and so on, terahertz.
We answer this question afterwards. Welcome, applause for our Federal Councillor Ignazio Cassis. Thank you very much for being with us.
Okay, so I think we stop at this moment and we will continue with the questions we have prepared tomorrow. Now, I have the great pleasure today, as you have heard, to have our special guest tonight. He just flew in from Zurich, you heard, our new Bundesrat, il nostro consigliere federale Ignazio Cassis, l'ospite d'onore dopo il nostro Federico Capasso. Infatti ho deciso di passare 2 minuti per riassumere brevissimamente per il nostro consigliere federale quello che abbiamo sentito questo pomeriggio. Il programma lo conosce e dirò che abbiamo avuto un pomeriggio estremamente interessante appunto con il premiato Federico Capasso che ci ha indicato le rivoluzioni che ci attendono e le cosiddette disruptive technologies che cambieranno completamente il campo classico dell'ottica e che quindi farà sparire in breve tempo, lo vedremo anche noi, moltissime ditte che costruiscono lenti e macchine, eccetera, macchine fotografiche e così via, e cambierà completamente le strutture e avrà un impatto anche enorme nel comprendere climate change e altre cose. Poi abbiamo avuto il cambio, diciamo, di questo highlight verso quello che è il tema di oggi e di domani, che è la digitalizzazione, l'impatto della digitalizzazione sulla formazione, sui posti di lavoro e quindi in questo secolo, e quindi abbiamo ascoltato alcuni rappresentanti sia dell'economia, il capo dell'economia di Zurigo, Rudolf Minch, e Laura Perret du Commun, sindacalista, e quindi direi è il momento adatto a questo punto per fare un piccolo riassunto, e dopo quello che ci ha detto il nostro presidente dell'ETH Arat, Fritz Schisser, che ha dunque il cappello di quello che è, diciamo, il front of our research, la nostra ricerca di fronte in questo contesto, quindi di ascoltare cosa è il messaggio, cosa il Consiglio federale, in particolare il nostro consigliere federale Ignazio Cassis pensa in questa direzione. È con particolare piacere, perché è oramai dal 1999, se mi ricordi bene, che non avevamo un rappresentante a Berna che fosse in grado anche di parlare la lingua in modo tale che lo comprendiamo in ogni caso, e quindi ci fa particolarmente piacere che questa sera sia in grado di essere qui a Lugano. Tante grazie a Ignazio per essere venuto, e il palco è tuo.
Buonasera a tutti e a tutte, è un gran piacere e un onore essere presente questa sera, e ringrazio per l'invito. Proprio ieri sera ho avuto il piacere di aprire il Salone delle Invenzioni a Ginevra, aprire ufficialmente, e quindi di chinarmi su un'altra realtà, quella più pratica dello sviluppo, ricerca e sviluppo, con 800 espositori, in buona parte il 60% dall'Asia, e capire anche come sta girando il mondo sulle prospettive future. Signor Presidente dell'Accademia Svizzera delle Scienze, eccellenti partecipanti a questo simposio, il termine digitalizzazione si è imposto nel vocabolario comune dopo il World Economic Forum di Davos nel 2016, ma in realtà la rivoluzione digitale è iniziata da oltre un quarto di secolo. Quindi saluto favorevolmente la riflessione che state conducendo sugli effetti della digitalizzazione nel mondo del lavoro e della formazione. Si tratta di temi che stanno molto a cuore al Consiglio federale, in particolare al mio collega e consigliere federale Johann Schneider-Ammann, capo del Dipartimento dell'Economia e qui rappresentato dal segretario di Stato Mauro Dell'Ambrogio, che dovrebbe essere, ecco, che è in sala e che saluto molto volentieri. Anch'io però, come Ministro degli Esteri, vorrei dare un contributo a questo dibattito. Vi racconto quindi un sogno che ho e che mi piacerebbe realizzare, magari anche con il vostro aiuto. Die Digitalisierung ist ein weitreichendes soziales Phänomen, das viele Aspekte unseren täglichen Lebens grundlegend verändert. Das Wort Digitalisierung ist heute in aller Munde und löst sowohl Hoffnung als auch Angst aus. Es braucht Maßnahmen, damit wir auf internationaler Ebene wettbewerbsfähig bleiben und den Zug nicht verpassen, würde man auf Berner Bürokratendeutsch sagen. Was aber kann die Schweiz konkret tun, damit sie weiterhin hervorragende Leistungen erbringen und sogar eine führende Rolle im vielversprechenden Bereich der Digitalisierung übernehmen kann? Heute Abend möchte ich über diesen Traum sprechen. Die Schweiz wird weltweite Leaderin im Bereich der digitalen Governanz. Damit könnte unser Land seine Rolle als internationale Plattform festigen. Avant toute chose, j'aimerais dire quelques mots pour vous expliquer ce que signifie aujourd'hui cette Suisse internationale. Le moteur se trouve, vous le savez, dans la Genève internationale. L'Office de l'ONU à Genève est le premier siège des Nations Unies devant New York en termes de personnel. 43 organisations internationales sont implantées en Suisse, dont 37 à Genève. 176 États y sont représentés par une mission permanente et plus de 380 ONG ont choisi Genève comme domicile. Mais tous ces chiffres, aussi impressionnants soient-ils, ne nous suffisent pas. C'est là, dans cette cité, que de nombreux défis trouvent une solution. La crise migratoire, le changement climatique en font partie, mais la liste ne s'arrête pas là, loin s'en faut. Prenons par exemple un objet que vous connaissez bien, le téléphone portable que vous avez, la majorité parmi vous, dans votre poche. Qu'a-t-il à voir avec la Genève internationale? Vous pensez peut-être à l'Union internationale des télécommunications, qui nous permet de téléphoner d'un pays à l'autre sans difficulté. Ou vous pensez éventuellement aussi à l'Organisation mondiale du commerce, qui définit les règles qui encadrent la vente et l'achat de ces téléphones entre États. Pas moins de 8 organisations internationales basées à Genève sont impliquées dans la production et l'utilisation d'un téléphone portable qui est un instrument, l'instrument par excellence de la numérisation des 30 dernières années. Par exemple, l'Organisation mondiale de la santé nous protège de potentiels effets négatifs pour la santé. L'Organisation internationale de normalisation, ISO, établit et publie les normes auxquelles toutes les composantes du téléphone doivent répondre. Ou encore l'Organisation mondiale pour la propriété intellectuelle, qui délivre les brevets et protège les marques. Et le CERN, qui a bien sûr développé le World Wide Web, voilà bientôt 30 ans, sans lequel votre téléphone serait simplement un téléphone portable e non pas un smartphone. Il ruolo internazionale che la Svizzera ricopre è frutto di una lunga tradizione, ma non deve essere dato per scontato. Ginevra è sempre più sotto pressione in competizione con altre città che vorrebbero sostituirsi ad essa. Bonn, Vienna, l'Haia, New York, solo per citarne alcune. Che cosa possiamo fare per mantenere questo ruolo di centro nevralgico del buon governo? Certamente garantire le migliori condizioni quadro per vivere e lavorare a Ginevra, stabilità politica, amministrazione pubblica efficiente, infrastrutture solide, buona formazione, finanziamento come Stato ospite, eccetera, eccetera. Ma non basta, dobbiamo soprattutto anticipare i bisogni globali di domani, l'intelligenza artificiale, i big data o appunto la regolamentazione dello spazio cibernetico, cioè nient'altro che il buon governo di Internet, good governance. E qui si colloca il progetto di cui vi ho riferito in partenza e che è un po' il mio sogno. Il nostro Paese è da anni al primo posto delle classifiche mondiali dell'innovazione. Le nostre università, i Politecnici federali, e saluto il Presidente del Consiglio dei Politecnici, il Professor Schisser, e i vari centri di ricerca in Svizzera godono di una fama internazionale. Abbiamo tutte le competenze per contribuire alle sfide che le nuove tecnologie comportano per l'intera umanità. Restiamo per un attimo nel territorio che questa sera ci ospita. Prendiamo l'esempio dell'Istituto Dalla Molle per gli studi sull'intelligenza artificiale, che è un fiore all'occhiello della ricerca Made in Ticino. Neanche 60 collaboratori hanno contribuito allo sviluppo di tecnologie per la finanza, la protezione dell'ambiente, la salute. Nella Svizzera italiana si è così creato un motore di sviluppo economico che attira altre idee. Lo scorso mese di gennaio UBS ha annunciato l'apertura di un centro di ricerca sull'intelligenza artificiale a Manno, che darà lavoro a 80 collaboratori altamente qualificati. Notre département entend lui aussi apporter sa contribution. Nous travaillons actuellement sur le message qui définira pour les années 2020 à 2023 la stratégie de la Suisse comme État hôte, Gaststaat. Parmi les mesures prévues, nous voulons positionner la Suisse comme centre de compétences pour les thématiques émergentes que sont notamment la numérisation, digitalisierung et l'intelligence artificielle. Pourquoi alors ne pas combiner le savoir de nos polytechniques, de nos universités, avec celui que possède la Genève internationale en matière de gouvernance? Il y a 30 ans, la Silicon Valley a été plus rapide que nous dans l'exploitation du web. Cette fois, ne nous laissons pas devancer par les autres. C'est cela notre projet. J'en appelle à vous aussi. Continuez à mettre vos compétences, vos idées et votre talent au service de la Suisse et à rendre ce pays plus smart. La Suisse doit rester une terre fertile pour l'innovation. E chissà, potrebbe anche nascere un polo di governance digitale proprio qui, nel Luganese, dedicato all'intelligenza artificiale nel mondo delle finanze e delle criptovalute, la Crypto Valley Ticino. In conclusione, un solo auspicio: dobbiamo avere il coraggio di guardare insieme oltre l'orizzonte. In questo senso vi ringrazio per avermi invitato a esprimervi queste parole e aver avuto la cortesia di ascoltarmi e vi auguro una buona serata.
Tante grazie. C'è un regalo di Ticino, perché forse quando è a Berna ho un po' di nostalgia. Grazie.
Grazie mille. Molto gentile.
Siamo oramai alla fine della giornata, molto intensa questo fine di pomeriggio. È particolarmente per me un onore e un piacere avere la Presidente, dopo il Presidente della SUPSI, la Presidente dell'USI, Monica Duca-Wittmer, a porci dunque le osservazioni finali. Monica.
Onorevole consigliere federale, carissimo Presidente, gentili signore e signori, è stato un vero piacere oggi sentire la diversità dei vostri approcci, proprio nello spirito delle accademie svizzere, quello di valutare tutte le problematiche in modo trasversale. I would like to start my closing remarks with a Chinese proverb: when the wind of change blows, some people build walls, others build windmills. All of us are convinced that it's time to build windmills. In our society, digitalization is joined with a high degree of uncertainty, mixed with a lot of expectation. This symposium embraces the opportunity and the challenges of digitalization. As Rudolf Minch said, Switzerland has to adapt to the digital revolution in order to remain the most innovative country in the world. Or Alberto Petruzzella, who said that we have to prepare ourselves for this change with an open mind, with flexibility, and above all, by investing in education. Risk or opportunity is the question raised by Laura Perret-Ducommun. The answer is that we have two sides, the opportunity and to be positive. The science world will help us. Federico Capasso and Fritz Schisser pointed out that science and technique will play a key role in its development. Education and digitalization are both complex on their own, and combining them in a way that makes sense is a greater challenge. I would like to congratulate Maurice Campagna and Claudia Penzeller for their great idea to provide this important platform and to make it happen. A big thank you, and thank you to the board of Digital 21 and to all the people that worked on it and supported. I hope that this platform will be developed and grow as heritage for the outgoing president for the Swiss Academies of Arts and Sciences, Maurice Campagna. Different actors in the area of the education, research, innovation and economics have the possibility to work together and exchange experience and knowledge. At the end of the symposium, the output of all this interaction will be useful to develop recommendations and to establish cooperation and future projects. It is necessary to help educators to make an appropriate use of digital technology and to develop competence and skills needed by the digital transformation. But the most important aim is and will remain to form and to educate young people with critical thinking. We need citizens able to judge and recognize misinformation, able to discerning the right ethical use of the digital technologies, able to leave school as good human beings and well-balanced members of our society, and not only as specialists. Siamo già nel mezzo della rivoluzione digitale, i cyber physical system, l'internet delle cose, sono già ampiamente applicati nella produzione, nei trasporti e anche nella vita di tutti i giorni. La sfida è quella di non lasciarci travolgere da quello che scienza e tecnica hanno reso possibile e renderanno possibile, ma essere in grado di gestire criticamente queste possibili innovazioni. L'auspicio a tutti noi è che questa rivoluzione digitale possa essere pilotata in modo da contribuire al progresso della nostra società. E progresso non significa quello che viene dopo, ma quello che porta vantaggi a tutti, senza esclusioni e che migliora la qualità della nostra vita. Vi ringrazio e auguro a tutti voi ancora una buona serata.
E adesso vorrei prendere l'occasione di ringraziarvi. Soprattutto vorrei ringraziare a tutte le istituzioni qui vicino che ci siamo raccolti così con braccia aperte. La SUPSI, la USI, la IUFF, siamo stati molto contenti e con la digitalizzazione abbiamo messo un tunnel tra Ticino e tra Berna e abbiamo lavorato molto intensamente assieme. Vorrei ringraziare mia collega Franca Siegfried per aver fatto uno blog su Digitale 21 per un anno per riflettere sempre più problemi e opportunità della digitalizzazione. E soprattutto vorrei ringraziare a 3 persone che hanno accanto al loro lavoro investito tanto tempo per fare possibile questa digitale 21. Prego di venire su scena Karin Spicher, la mia collaboratrice, Giovanni Zanarit della USI, che sfortunatamente non è qui perché si occupa delle medie, e Rina Corti della SUPSI. Un grande applauso.